Hello guys, welcome back to DSA playlist by 2am Coder. If you're first time in this channel, this is one of the best DSA algo playlists out there for beginner, and if you haven't subscribed to my channel, I definitely recommend you to go watch out my videos and subscribe to my channel. In our previous video, we have talked about introduction of big O notation, and in this video, we are going to talk about some of the big O notation step by step and how they actually work. So without further ado, let's get started. So guys, in our first introduction video of big O notation, we have seen that big O notation is nothing but a way to analyze the complexity of the program, and we have also seen what is this graph and how these annotation are indicated here, what is this x-axis and what is this y-axis. So I'll just quickly recap everything. As I said, it's a way to analyze the complexity of the program and also depends upon the input size, or you can say input data size. If that size increases, complexity of the algorithm may also vary. So x-axis is nothing but the size of input data. If input data is array, size of the array will represent the x-axis and y-axis represent the operation, which means if you are running any loop, how many times that loop is iterating or how many times that loop is executing, so that represent the operation. And with each input data size, how many times the particular loop or any method is executing, that means what is the operation. With that tracing, we find the particular complexity graph, right? So in this video, we are just going to focus on big O of 1 and big O of n, how these graphs are created here and which algorithm takes this particular order of complexity. So let's jump into that. So guys, the first big O notation from the list is order of 1, which is also known as constant complexity. So why it is called as constant complexity? So basically it does not depends upon your input data size. Actually, doesn't matter if your input data size is 5, 10 or 100, it will just going to take one step to execute the program. So your algorithm will have only one operation. So that's why it is called as order of 1. So let's try to understand this with the help of one example. Let me create one array here. So guys, this is some random array with random size. Okay, so I just need to find any element which is present in, let's say, index number 4. So how will I get the element from index number 4? So we will get the fourth element in the array just like this. So you don't need to do anything else. You will get the fourth index element from the array by calling the 4 index from the array, and you will have the element in the result variable. Okay, so you can see this is nothing but one of the best example of order of 1 complexity, where you don't need to do anything to get the any index value from the array. Let's say if you want to get index number 6 element, so result 2, you will just get it like this. Okay, so now result will have 0, 1, 2, 3, 4, 5, 6, 8. So result value will be 8. So you can see there is no other operation, it's just one line of code. With the help of that, you will get the result. So even if I change the input size, let's say if I make it, if I increase by 3 more element, your complexity of this particular program will not going to change. Anyway, it will get the 4th index with just this code and 6th index element with just this code. So you are not doing anything extra to get the element. So that's why we call it order of 1, because it will just take one step to get the actual result from your code. So that's why we have kept it in the x-axis only, because even if you change the input data size, let's say if you make it 5 or 10 or maybe 15, it will just going to take one step. So it will be a constant one straight line. That's why it is in the x-axis only. So I hope you have understood the constant complexity, which is order of 1. So by the way, this is nothing but a time complexity, and we are just trying to understand time complexity of any big O notation. So let's suppose if your algorithm doesn't have any loop, or it's just a straight method and one time execution, so you can say that it's order of 1 complexity, like what we have seen here. Okay, so I hope you have understood this. So let's jump to our next notation, which is big O of n. So guys, second big O notation from the list is big O of n, which is also known as linear complexity. So why it is called as linear complexity, you can see it is clearly mentioned here is big O of n. So that means it depends upon your input data size. So n here is nothing but, I can mention here, n is equals to input data size. Okay, so n is nothing but your input data size. Let's say input is some array and size is 5. So if your input data size is 5, the complexity of particular program will also be 5. So this indicate that your input data size will be equal to your order of complexity. Okay, if it is 4, the complexity will be 4. That means it will have 4 number of operations or 4 iteration. If your input data size is 10, let's say if array size is 10, then it means it will have 10 operation to execute that particular program. So one of the best example for this particular notation is nothing but linear search. So we have already done the video on linear search. If you haven't watched this, you can directly go to my YouTube channel, or you can click on the I button which is displaying on top right corner and you can watch the video. So guys, let's jump to the IDE and let's try to understand how we can draw order of n graph here with the help of linear search example, or you can say that how linear search will have the complexity of order of n. Okay, so let's jump to the IDE. So guys, till now we have done these many videos on recursion, searching and sorting. We just need linear search. So guys, this is the linear search program that we have already done in our previous video. So we are just going to run this right now. So 12 is present in 6th position, and we will also display some of the information which we need to draw the graph. So basically we need the elements, that means size of the input data, which is an array in our case, and we need operation. Operation means how many times that particular loop or any method is executing. So first of all, let's display this size. Let me remove this from here. So it will display the size here. You can see size is 12. Let me search 15. Okay, now we need operation as well. So for the operation we need one counter. So let me initiate one counter here. Initially it will be 0, and for each iteration of the loop we are going to increment this, and we have to display this as well. So let me copy this from here, paste it wherever we are returning from the method. So we are returning from here, and one place is here, counter. Okay, so all done. Let's run the program. Size is 12 and counter is 7. So that means to get the target from this array, it has to execute 7 times, and this is the current scenario, and we know the target element, right? What if we don't know the target element, and if the target element comes in last position? That is one of the case, right? That is possible. So in that case, what will happen? It will execute same number of operation which is equal to your array input data size. And let's suppose if you are searching anything which is not even present in the array. So let's say I'm searching 415. Even if I run the program and now see the result, size is 12 and counter is 12 again, because it will search 415 in each index till the last index. So you can see it is executing equal to your input data size, right? So let me reduce the input data size to 4. So you can see size is 4, counter is 4. Okay, so I'll go to the graph and we will draw this. Okay, if input data is 4, it will execute 4 times. It will come here. Now if I increase the input size to something else, now if I run the program, you can see size is 10, counter is 10, because it's not even available in the array. And we are considering the worst case here, because if you are searching number 9, let me search 9 here. You can see counter is 1. That means this algorithm, which is a linear search algorithm, will going to find the element which is 9 in the first iteration only. So you don't need multiple iteration for that. But here you know the target and you know that it is present in the first position. But there may be some cases you don't know the input data or you don't know the target element also. So in the real case scenario, so in that case you should consider that it will going to execute order of n times. Let me write 91 here, and now it's going to counter 10. Let me draw this. 10 is here. It is executing 10 times, which is equal to this, which will come somewhere here. Okay, so we will draw this. Okay, so this is nothing but the linear graph. I think you might have aware about this, that this is linear graph, big O of n. So big O of n is nothing but the order of complexity, which is directly dependent upon the input data size. If your input data size is 10, the complexity will be 10, and if your input data size is 100, your order of complexity will also be 100. So linear search is the best example for order of n complexity, where n is nothing but your input data size. So I hope you have understood this particular notation. We will also see other big O notation in our upcoming videos, so just stay tuned and subscribe to my channel. I'll definitely see you in the next one. Till then, see you, take care.